Welcome everyone, this is C++ Club meeting 160. And we have our first guest today. Frances Buontempo joins us. She's a software engineer and consultant based in the UK, the editor of ACCU's Overload magazine. And her About Me page says that she can program her way out of a paper bag in a variety of ways. Frances is writing a new C++ book. So do you want to talk about it?
Yeah, sure. So I'm writing this book for Manning. It's in their early access program at the moment. So there are 5 chapters up. The 6th one's going through review at the moment. I've focused it on people who used to know some or even lots of C++, but have maybe got left behind by some of the recent standards that have been released. So I'm going to have 9 self-contained chapters. The first one's just an overview, and then after that they've each got projects in, including 6, which is in the pipelines, allows you the opportunity to code your own way out of a paper bag using some random number distributions. I think this is a skill everyone should practice at some point.
Yeah, so this is the Manning book webpage. It's currently in early access. There are several versions of the book. It's available in a variety of formats: ebook, print. Ebook is Kindle, EPUB, and PDF. Plus, interestingly, something they call a live book. It's basically a web version, and it's very convenient in the sense that it's got all the links. And the most interesting part is there is a live book discussion forum where readers can discuss the book as it's being written, which is a new way of writing books, I guess.
That's allowed some people who are reading it to leave comments as well, saying, could I do it like this instead? So I've been engaging with some people who've bought it. That's been quite useful, having the quick feedback. And of course, some people who are reading through spotted better ways of doing things than me. So we've all learnt something.
Yeah, it's an interesting way of getting feedback, definitely. Quote from the book: C++ is an old but evolving language. You can use it for almost anything and will find it in many places. In fact, C++'s inventor Bjarne Stroustrup described it as the invisible foundation of everything. And regarding the target audience, quote, this book is aimed at people who have used a little or even a lot of the language and lost track of recent changes. It's nice that the live version of the book has a copy button for code snippets that you can try. And also, I liked that whatever external information or website you are mentioning, there is a link to that, which is really, really useful. Maybe a small thing, but thank you for not using std_endl in the example code.
Yeah, I have a rant about that, and I'm not the only person. If you want a new line, ask for a new line. If you want a new line and to flush the buffers and do loads of other things, okay, knock yourself out. But if you just want a new line, use a new line.
Yeah, I don't think I've used it for a decade and a half.
I think there might be a misconception where people think that if you use std_endl, it provides us a magical cross-platform way of ending the line, which is not true, really. One question I had was, how long did your internal debate last on whether or not to write another book on C++? Or was it like a spontaneous decision, I'm writing a book now?
It was a mixture of looking at my huge pile of C++ books and going, there are a lot of books. But what has actually happened was I'd reviewed a book for Manning with lots of tiny C projects in. And I thought, despite my huge pile of C++ books, none of them have got that kind of small self-contained projects. And I remember reading, I think, Koenig and Moo's Accelerated C++ ages ago and finding that really useful, because that had got some small self-contained examples just to get you the hang of the basics. If you wanted deep dives into precisely what was happening in the background, go for the big stack of books. And I've not seen anything like the accelerated C++ recently that just goes, look, here's a few small things just to give you that leg up so you can then do the deep dive afterwards. And then I said to myself, no, for heaven's sake, don't write another book. You're far too busy. But I'd already volunteered by then, so it was too late. So, yeah, it doesn't cover in-depth different versions like C++ 17 or 20 or so on, and everything. If you want to know everything, you'll need to read all the other books. But like I said, it's just aimed at people who just want that little self-contained, get yourself up and running a bit. So get you started again.
Right. Yeah, makes sense. I especially liked one thing about the book, that while discussing a particular task in a chapter, the book explains all the aspects of C++ needed to solve it, like going here and there and covering various topics, as opposed to dedicating a separate chapter to a single C++ topic that most other C++ books do. And this to me feels closer to how C++ is used in practice. So it's like a simulation of, frantic Googling when you want to solve something. So I thought that was very good.
If you try and write code to do one thing you've learned, you usually end up having to do something else, like write to a file or read some input or something else as well. And then you go, I could have done it in ranges. So despite the title chapters, there's several other bits in every single chapter, just that all fit together into the one project. Life's like that, isn't it?
Indeed. Well, thank you very much for talking about the book. And everyone go and check it out. And I'll be reading it as it's being written, which is a bit of a new experience, but yeah, very interesting. Thanks. Right. This is your blog. And this is a very good ACCU Overload magazine that I make sure to read whenever a new issue comes out. It's very good.
Thank you.
And this is your Twitter account. Oh, you're on Mastodon. Yeah. Nice.
I'm on Twitter, and my Twitter handle's got a link to Mastodon as well, so you can find me in either place.
Excellent. I ceased all activities on Twitter myself.
Fair, yes.
Right. So a bit of a feedback on earlier feedback. Last time we talked about Roy Barkan's comment on the earlier video on YouTube about a paper on using auto curly braces X for decay copy, due to which it couldn't be used for the proposed short concepts notation. And the paper seems to have been accepted, plenary approved for C++ 23. This is the paper by Zhihao Yuan, and it proposes auto parenthesis X and auto curlies X for transforming X into a PR value with the same value as if passed as a function argument by value. So it's basically decay copy. And we weren't sure last time if it was accepted or not, so it looks like it is. And this is the GitHub page for the paper, and it has the C++ 23 tag. There was an interview and Ask Me Anything session with Bjarne on the Exercism YouTube channel. And it was very interesting. The chat was pretty active, and the questions were interesting. So I encourage you to go and check it out. Obviously, there were some silly questions in the chat, like, what do you think of Rust? And what about ChatGPT? And Vim or Emacs? And why is C++ so hard? But there were some good questions too. So
I never saw that list of questions. I only heard the ones that was repeated to me by John.
Yeah, luckily he filtered all the chat.
It's more or less a requirement these days when I give an interview that somebody relays the idea of keeping track of all the questions and then choosing the right ones It's just too hard to do in real time with answering other questions at the same time.
Yeah, it's definitely the work of the host, not the interviewee.
Yeah. It gets much better as a conversation when that's done that way.
Yeah. Right. So April mailing has dropped, and there were quite a few papers, and I wanted to look at some of them. The first one is revision 1 of the paper Do Expressions. It's by Bruno Cardoso Lopez, Zach Lane, Michael Park, and Barry Revson. Apparently, there is prior art for this. GCC has had an extension called statement expressions for decades, which look very similar to what we are proposing here, they say. GCC extension uses a combination of parentheses and curly braces to designate a block or statement expression. But the proposal differs from this in two critical ways. The first is the ability to specify a return type, which is critical for allowing statement expressions to be values. And the second one is the ability to support yielding out of different branches of if due to the implicit nature of the yield. So yeah, hopefully this progresses well and we get it, maybe in C++26.
I haven't read this proposal, but I'm excited about it because I have frequently been forced to create a Lambda function and call it immediately, an anonymous Lambda, to emulate this. And syntax is rather horrible. So,
Exactly.
And usually it's about keeping local variables sufficiently local, being able to declare something and then know that it will go out of scope fast enough.
Yes, this is very exciting. Next is Uniform Call Syntax for Explicit Object Member Functions by Gasper Ajman. Quote, this paper introduces a unification of hidden friends in explicit object member functions to allow a limited but hopefully uncontroversial uniform call syntax for them. Unlike the previous proposals on this topic, this one avoids pretty much all controversy. End quote. I imagine committee members seeing this and going, I'll be the judge of that.
I have never seen an uncontroversial proposal. There's always somebody who objects to something.
Yeah. So this is the example code. Basically, you define a friend inside the class declaration and like a hidden friend idiom. And then you'll be able to call it as a member function or as a free function. So that's it. The proposal only applies to this hidden friend idiom. The next one is trivial infinite loops are not undefined behavior by J.F. Bastian. Quote, C and C++ diverge in their definition of forward progress guarantees and have done so since C++11 and C11 added a memory model and acknowledged that threads exist. C does not make iteration statements whose controlling expression is a constant expression undefined behavior, whereas C++ does. C++ implementations therefore assume that even trivial infinite loops must terminate. This is unfortunate because using an infinite loop is a common idiom in low-level programming, particularly when a bare metal system or kernel must halt progress. End quote. So this proposal is about making trivial loops not UB, and they define trivial loops in a certain way. Yeah, I don't know exactly how they are going to distinguish between trivial and non-trivial loops, but I can see that it's, I mean, in my early days, I did program for a small embedded system, like a payment terminal, and there was an infinite loop that ran everything basically, so I can recognize it as a problem.
How did the program interrupt? Was there some sort of signal handling the external button being pressed or something?
Yeah, I think it was interrupt based. It was a long time ago.
Perplexed about the premise. Is it true that just writing while true asks the user, do you want to quit? If the user says yes, break, is undefined behavior right now in C++?
No, I don't think that's what it claims, right? It can be.
I think if there's no, I think the progress is required. So the code must end at some point. So infinite loop is a UB.
Maybe if the compiler can demonstrate that in no case the if becomes true and then in no case the program will break, then there is a problem. But otherwise, I think it should be fine.
The problem with it, I think, is that if the compiler cannot demonstrate that it's not UB, then it just assumes that there's no UB and optimizes it away.
So.
So, yeah, tricky.
There are programs that in principle runs forever. And the way you stop them is to disconnect them from the power source.
Yeah, but that's also UB, isn't it?
Well, such things exist for good reasons.
Yeah. The next is Contract Violation Handlers by Joshua Byrne. Quote, custom violation handlers turn an overly simplified contracts facility that is highly ineffective in many environments into a moderately flexible and practicable one. In short, I think this adds a contract violation handler semantics back to the minimum contracts proposal, which currently doesn't have it. And it says the C++20 contracts prior to their removal describe a conditionally supported mechanism for installing a user-supplied contract violation handler with appropriate semantics. And the paper says that handling contract violations via user-provided callback is an established, well-tested approach that is deployed in many modern assertion facilities. But the current MVP has no mechanism for altering the behavior on contract violation. And as you may remember, there are only two options. Either contract conditions are not evaluated, or they evaluated and any violation terminates the program.
As you know, I don't think the minimal viable proposal is viable because of the absence of alternatives to termination. And I have not read this version of this paper, but it's plausible. I mean, the general approach is plausible, and the devil is in the details.
Yeah. So the next paper is trying to explain the idea behind the contracts MVP by Andrzej Krzemienski. And it sort of tries to justify the contents of the MVP, including the fact that only two outcomes are provided, and it tries to validate the fact that there's no need to supply any more options and everything can be added afterwards. But in practice, it's going to be tricky. And this is what the next paper is about. Next paper is called Unconditional Contract Violation Handling of Any Kind is a Serious Problem by Ville Voutilainen. Quote, this paper explains why we shouldn't have hard-coded eval and abort and eval and throw modes in the contracts MVP, and further explains why we should have a violation handler instead. For those in a serious hurry, go read Joshua Byrne's paper, the one that we just mentioned. In this paper, Ville argues that adding more options afterwards, after the MVP is accepted, might not be even possible That is, it will theoretically be possible, but in practice, as Bjarne said many times, if you link against a program that only has two of those options, then you basically are stuck with that. And there is no guarantee that your program will not abort at some failed contract violation. You may not always have an option to recompile everything with the new contract flags. So in this particular case, it looks like this needs to be done right from the start.
There's a sort of a political reality. That is, if you give people half of something, then some people are satisfied with that, and then the number of people who will support it goes down because they've already been satisfied, and the people who thinks that the original was enough will be against it. And so I think it's actually a disingenuous argument unless we are in a very specific situation so that there's no controversy about the potential extension. And all of the potential extensions here have been shown in the worst possible way to be controversial.
Yeah, as past experience shows, contracts is a very controversial proposal.
The MVP, for instance, I would have to object to any use of it in the standard library, because that would instantly make the standard library useless to, I think, significant number of application areas.
So I guess I'm new to this debate. Maybe someone can enlighten me a little. What's the two use cases? I understand one use case of contracts is to help prevent undefined behavior. And in that use case, the assumption is every contract violation will certainly lead to undefined behavior. An example of such an implicit contract today is the brackets operator on the standard vector. And in that case, your two modes are, I trust I have no undefined behavior, so I'll ignore, and I don't trust I have no undefined behavior, so I'll terminate so as to prevent undefined behavior. That seems like a very limited use case, but I understand it. What's the use case where you're using contracts to protect from something that isn't undefined behavior and expect happy recovery?
Don't think happy recovery is a good description. What a contract should guarantee is that you don't pass it. That is, you don't get into the state that will come after the contract and therefore get you into trouble. And there's three ways of getting out of that. One is to guarantee at compile time that the program won't run. The second is to terminate, and the third is to throw an exception. And the most common response for throwing an exception is clean up and exit or reinitialize, or write a log message and terminate or reinitialize, something like that. The thing that, in my opinion, mustn't happen is to carry on beyond the point of the contract that has failed. But the Bloomberg people claim that that's actually an essential use case. That is, they want to log and continue. I'm not so sure about that, but that's another situation where they claim that you never get your contract right the first time in an existing program, and therefore you want to use them as a debug mechanism, the way some people use a garbage collector as a debug mechanism to find leaks.
Got it. So basically, sometimes you use contracts to prevent undefined behavior, like I said. Other times you use contracts to stop before you would cause undefined behavior, and you can trigger exceptions and destructors and stack unwinds and things to sort of terminate only a piece of your program to avoid undefined behavior. And other users want to use contracts as a mechanism not to prevent undefined behavior, but to prevent behavior they don't like.
That's true, but also to prevent undefined behavior by not getting to it.
Yep.
So the time travel has to be stopped somehow.
Right.
There was a proposal we discussed previously that suggested separating your program into components, and each component could be terminated separately without affecting the rest of the program. That was supposed to help with the termination option of contract violation handling. So
that would have touched an enormous part of the language and an enormous number of existing programs.
Yeah. Right. There is a Reddit thread on the mailing. And the first question is, what is going on with reflection? For something that's supposed to be a focus for the next 3 years, I see very little movement on it compared to executors. Someone says, the SG7 mailing list looks dead. 5 emails in a year is not inspiring. And SG7 didn't have any telecons as there was no paper addressing SG7. And the group did not meet. So it's a bit depressing.
Nothing happens unless somebody drives it. And the people who are driving reflection basically walked away from it. And I think most people who could have taken over are busy with other things.
That's very unfortunate. There is some discussion on including algebra, linear algebra in the standard with different takes, like there's no place for it in the standard versus it should be in the standard. The usual. Someone compares it to graphics and they say that graphics wasn't properly defined or something, whereas linear algebra, BLAS-based, for example, is pretty much exists already, and it would be good to have it in the standard. Next, someone posted on Reddit, stop comparing Rust to old C++. Quote, people keep arguing migrations to Rust based on old C++ tooling and projects. Compare apples to apples. A C++20 project with Clang tidy integration is far harder to argue against, in my opinion. And actually, it's a refreshingly calm discussion on the pros and cons of both Rust and modern C++. For example, pros. Quote, there is a lot that Rust has going on for it that C++20 does not have, leaving out the usual memory safety and thread safety language features that people are probably aware of already. Build system stuff and dependency management, and even packaging for simple enough apps, are basically a no-brainer in Rust. Coming from C++, this alone is life-changing. Moves are destructive, so there is no use after move, no fuzzy moved from state. Pattern matching as a language feature is incredibly powerful, and it's not bolted on after the fact, as it maybe will be in C++, but the language was designed around it. And for me, it's a point of envy. I'm looking forward to pattern matching. The quote continues, most defaults that people often wish were different in C++, starting from constants and barring surprising implicit conversions, are fixed in Rust. Unit and integration testing is also part of the language, and unit tests can be put next to the code they test. And for the cons, quote, as someone who uses both Rust and C++ near daily, I always miss C++'s type system in Rust. Rust type tools are very weak by comparison, and the fallback macros are royal pain. I've been working on an archetype ECS entity control system library for games. This is essentially a processing engine for arbitrary tuples in struct of array data structures. The lack of variadics and the weakness of trait expressions, no specialization, no negative constraints, combined with the orphan rule, has made it pretty unpleasant to do it in Rust. If I want the work to be done at compile time for runtime performance reasons, I'm basically stuck with one giant mega crate containing all of the code in question created by very heavy proc macros. Most popular ECS libraries in Rust rely on a lot of RTTI and reflection-like functionality that isn't zero overhead. The equivalent library I've written in C++ is almost entirely compile time, with variadic tuples and tuple processing functionality, like using Sphinx to find all types in a type tuple that have a given function. Rust enums are great, but Rust generics are nowhere near as powerful as C++, and that weakness is compounded by Rust's strictness on coherence, the orphan rule, and lack of any duck typing." End quote. There are much more interesting and useful comparisons in the thread without hyperbole or too much emotion. But the usual caveat applies. Don't go too deep or too far into the thread, or you will encounter the increasing amount of C++ bashing and Rust propaganda. Consider this. Quote, "I also feel that people who just come to RCPP to advocate Rust are newcomers who completely fail to understand the purpose of Rust." And obviously there is this one. Quote, "You can smell the fear around here these days," says that person about RCPP. My eyes are stuck. The next one is Circle. We've touched this before, but I wanted to revisit it because there were some new posts about it. Circle is a new C++ 20 compiler. It's written from scratch and designed for easy extension. This is its homepage. This is the GitHub page with documentation and issues. And this is the Reddit thread about it. Someone posted on Reddit, "It is absolutely insane to me that one guy has both made his own C++ compiler and has also added some awesome compiler extensions to the language, like native shader compilation." There was a new post on Reddit by Sean Baxter, the author of Circle. The post is titled C++ Evolution versus C++ Successor Languages. Circle's feature pragmas let you select your own evolver language. And this is obviously a response to all the supposed successor languages to C++, including CPP2 and Carbon. And this is Sean's answer to that. So Circle feature pragmas let you kind of build your own evolver language syntax. Someone replies to it, "Having a facility to make source-breaking changes so that the language can evolve. Awesome. Having a knob for every feature so that everyone can design their own dialect of the language. Pretty bad, I think."
I mean, it's bad if you want to actually have a community around it, because then nobody knows what you're talking about. But maybe this tool isn't supposed to be just that, at least, maybe the main purpose was to experiment. And then, I think it's an amazing tool for that. So sounds good to me.
Someone said to that, "Works fine in other languages. Here is all the extensions you can enable per source file in GHC, Haskell compiler."
I once talked to somebody who had a new language, and the aim was to allow everybody to extend and improve the language so that you got the ideal language for every application. And this was done by facilities for modifying basically the AST, so that you could have your own syntax and your own semantics for everything. And I spent about 2 hours trying to explain to him that if he had his ideal language and I had my ideal language, nobody else could use both of them. And in particular, we couldn't communicate because sending a piece of data from the one to the other, there was no guarantee that it had a semantics that was defined. And you actually have to have a pretty rigid language that is shared by everybody before they start extending it. And a lot of these suggested improvements, especially if they're optional, and especially if they can change the semantics of existing code, goes in that direction. And therefore, I get worried about it. One of the strengths of C++, and probably even more so at C, is that the meaning of code doesn't change.
This person says, I never heard any Haskeller around me complain about it. Haskell is around me. The picture of John Travolta looking around. These fighting words from Sean Baxter go like this, quote, would you rather have the features you want, or would you rather deny others the features they want? We written in parse in C++ because the standard for changing anything is consensus. This is impossible in most cases. We should let institutional users who sponsor tool development lead the language in directions that they want it to go in. End quote. Ah yes, institution-specific C++ versions. What could possibly go wrong there? A Redditor points out an important detail. But Circle is not open source. Someone replies, unfortunately, this is a killer. No company is going to want to use Circle to build millions of lines of source code when it can cease development at any time with no recourse.
Two observations here. The reason C++ was standardized under ISO, leading to advantages and problems, was that argument was specifically stated by IBM, Sun, and HP to me. And that's how we got into that. Now, Sun with Java proved that this is not true. You can have a corporate language, and if you hand out enough goodies for free, people will give up their want with their principles and just use it.
Rust started as a company-specific language also. I think it was started at Mozilla as a way to program the Firefox browser. And only then it sort of developed into a Rust foundation. And this thing also is very important. Someone says about Circle, that might be cool, but will remain an academic exercise until there is Windows support. So since it's not cross-platform, many people can't use it either. Right. Herb Sutter posted, it's quite a while ago actually, CPP2 design notes, universal function call syntax, const, unsafe, and ABI. Basically, design notes for the design decisions that he took when working on CPP2, which I don't hear much about lately. I don't know.
It was in the recent CPP cast episode.
Oh, right. I hadn't listened to that yet. Yeah, that's true. I need to work on my CPP cast backlog. There is also a CPP2 design wiki, which is useful. It contains all the design information and the Reddit thread. This article, will Carbon replace C++?
Is that one of those questions in the title where the answer?
Yep. Betteridge's law holds up as usual. This article, written by Manuel Rubio, is written as if Carbon is already a language that's available, which is not exactly the case. And basically it reiterates everything that was said in the presentation about Carbon. The Hacker News thread on this notes that basically many comments express doubt about the title. Basically, the quote goes like this. C++ just doesn't have that many real problems. It has a lot of irks, but the problems people run into are problems that others already solved 1,000 times over the last half-century in many different ways, for many different iterations of the language. Pretending you can replace C++ is like pretending you can replace cars. Not just create electric vehicles, but straight up replace cars. Good luck, you won't succeed if that's your goal. So hopefully you realize you need to focus on making a decent language that some folks might consider using instead of C++ for some of their work, instead of creating the successor to C++. End quote. This is an interesting tidbit, not exactly C++ specific, but it's an illustration on how various memory errors can be mitigated. And it's about a virtual memory subsystem on iOS. Quote, on 64-bit Apple platforms, the entire 4 GB 32-bit address space is not accessible by the process, which catches both null pointer dereference bugs and 64-bit to 32-bit pointer truncation bugs. So yeah, I thought that was an interesting way of just preventing the entire class of...
Null pointer catching was common in the early days. All the Solaris systems did them, and I think some of the PDP-11s did. I mean, C++ has grown up with that as being a terminating error, not anything else.
Right, so that's not exactly new then.
Isn't it the case that in some platforms, some embedded platform, actually you can use address 0 as a proper address?
Maybe on some microcontrollers?
Yeah, I mean, a lot of embedded 0 is the jump address that then jumps the entry point of your firmware.
Also, there's always somebody that can do it. It's just whether it's protected for normal user level code. If there's a kernel, it can usually get there.
Yeah, pretty much all memories start from 0. The question is whether the memory is free for the application or whether there's any system data or anything else. So it's fine, but for example, on Linux, the first 4 megabytes are also unmapped to cache all the null pointer dereferences, just the same way as the iOS. It's very common.
And
all right.
I think this was true in the 80s.
I was just going to say that I think the ability to have a program terminate when it dereferences a null pointer has gotten worse over time because the optimizing compilers keep getting smarter. So the termination may in fact happen someplace where you don't expect. I've certainly done things like accidentally tried to call functions with a null this pointer and been very confused for a while because I get several method calls in before I discover what's going wrong.
Yeah, that's bad. And came as a surprise. It's been quietly coming out of core without any votes. I don't remember voting for time travel. And its implications of stuff I haven't actually looked at much.
So I had lots of compiler and IDE news. Visual Studio 2022 17.4 is available. And Handy Explainer article about Microsoft C++ versions. So we have 2022 as the name of the Visual Studio IDE. The actual version of the IDE is 17, I think. The compiler is 143. So yeah, pretty confusing. And this article is supposed to clarify that. But they keep using it. It's not like they're going to switch to an ultimate version number, like, for example, CLion did. And Visual Studio now has CMake debugger as well as CLion. It allows you to debug your CMake scripts, which is going to be pretty horrible, I think. Someone said, it's a build system configuration generator debugger. Lol.
I wish I had it, on VS Code, for instance. I don't know if there is a way to get it with an extension, but it sounds like a pretty useful feature to me. I keep having to put messages in my CMake to find out where I did wrong.
Yeah. I think that's all for today. I'll leave you with this post on Mastodon. Dave Rahaja writes, overheard from a program manager when talking about project status reporting. Watermelon status. Green on the outside, but actually red on the inside. And next one is a new book from O'Reilly. Essential copying and pasting from ChatGPT. And subtitle is Deploying Untested Code at Breakneck Speeds. Right. I think that's it for today. Thank you very much for coming, and I'll talk to you hopefully soon. Bye.
Bye.
Cheers.
Bye.